This is a Key Stage 3 chemical structures video looking at how we name compounds, how chemical reactions work, and how we can balance equations. So let's first of all look at naming compounds. Now, the first example is where we've got a metal and oxygen, and these always make metal oxides. We can see how the word oxygen has changed to oxide. So our example is magnesium plus oxygen makes magnesium oxide. Similarly, if we've got a metal and, for example, chlorine, but this could be bromine, it could be iodine, we get a chloride. Okay, so the change of the ending of the word is again ide. So we had metal oxide and we've got metal chloride. And our example is sodium plus chlorine makes sodium chloride. We can never say sodium chlorine, that's not a compound name. So we change the ending to show that a compound has been made. And in this case, it's sodium chloride. If we've got 3 or more different elements and one is oxygen, the ending becomes ate. So here you can see we've got copper, sulfur and oxygen, and we make copper sulfate. If it was just copper and sulfur reacting, it would be copper sulfide. But because there's oxygen reacting as well, it becomes copper sulfate. Let's look at what happens in chemical reactions, and this will lead us on to balancing equations. So, atoms just rearrange themselves in chemical reactions. They're not destroyed, they're not created, they just change their arrangement. Okay, so here we can see that 2 magnesium atoms went into the reaction, 1 molecule of O2, oxygen, went into the reaction, and then they rearranged. The oxygen broke its bonds, separated, and each oxygen joined with each of the 2 magnesiums. So we end up with 2 lots of MgO. So if we were to do this as a balanced equation, it would look like this. 2 magnesiums plus 1 molecule of O2 made 2 molecules of MgO. Let's look at that. There are the 2 magnesium atoms, the 1 molecule of O2 and 2 molecules of MgO. Same number of atoms of magnesium go into the reaction as out of the reaction. Same number of oxygen atoms goes into the reaction as out of the reaction. So, balancing equations can only involve changing the number of atoms or molecules, not changing the structure of the substance. When we balance an equation, we can only put numbers at the beginning. We can't change the structure of the molecule or particle arrangement. All we can do is change the number of total molecules or atoms that there are. This means we can only place numbers in front of the atoms or molecules. The aim is to have the same number of each atom on each side of the equation. So let's have a look at the second example. We've got 2 atoms of sodium, Na, and 1 molecule of chlorine, Cl2. So that means on the left-hand side of the arrow, we've got 2 sodiums and 2 chlorine. And each of those sodiums joins with 1 chlorine to make NaCl, sodium chloride, which is table salt. And we have 2 molecules of all of that, okay? 2 atoms of sodium on each side of the arrow, 2 atoms of chlorine on each side of the arrow. Now we've got an example of a neutralization reaction, hydrochloric acid with sodium hydroxide, making sodium chloride and water, and that equation is balanced. So we don't always need to put numbers in front of the molecules because sometimes our equation is already balanced. Hope you found that useful. Thank you.